So now we're going to talk about rotations on the coordinate planes. Rotations are a little bit trickier because you've got to turn that entire object. So the rules are a little more complicated to memorize, but we still have to do that. So let's first define what a rotation is. A rotation is a rigid motion that turns a figure about a fixed point. And that fixed point, the fixed point is called the center of rotation. So I'm highlighting that. The angle of rotation is the number of degrees the figure rotates. So we have to understand what a positive angle looks like and what a negative angle looks like. And it was discussed last year in 8th grade. But this is the standard format for all of the angle measurements on the coordinate plane all the way up through calculus. So a positive angle of rotation turns the figure counterclockwise. Now we have to think of a clock, an old-fashioned clock like the one that's on the wall of our classrooms, and think about what that, what is it called, the second hand, how that thing is rotating. Counterclockwise is going against the opposite direction of the way a clock normally moves. And then a negative angle rotation, that's going to be clockwise. So when we think of counterclockwise, we call that C. Oh, again, I got my fat highlighter here. Let me fix that first. Counterclockwise is going to be CCW. That stands for counterclockwise, and you're rotating like this. Think of your coordinate, your quadrant numbers. So if I come down here to my first drawing and I number my quadrants 1, 2, 3, and 4, counterclockwise is the direction going in the order of the way they are numbered. So counterclockwise is this way. Clockwise would be the other way, so we'd call that CW, and clockwise would be going around the other way, like the hands of a clock. So let's see what we can do here. Take the point 4, 2, and we're going to rotate it the way we have stated. We have 4 examples to do. So my point is already graphed. There's the point 4, 2. And I want to rotate it 90 degrees. Since 90 is positive, I'm going to rotate it counterclockwise. So here's what you have to do. Imagine a line connecting from the origin up to your point. And I want to rotate that 90 degrees. So if I do that, that means I'm going to create a 90-degree angle here. And that point is going to end up, looks like over here. Now one thing that's a problem is that the scale of the x's and the y's, if you look at this diagram, the x scale is a little bit wider than the y scale, so that might lead to a little bit of confusion. But if I do that, my new point is now up here in the second quadrant. And if I write that coordinate down, instead of being at 4, 2, I am at -2, 4. So there is a connection. The absolute values of the x and y's, we started at 4, 2, they're still there, but they're in a different location, and the front guy is now negative. So let's rotate 180 degrees. 180 degrees would be like drawing a line right through the origin. Remember, because 180 degrees represents a line. And again, it's a little confusing because my grid isn't square. So if I do that and I pop out on the other side, another way to do this is to count down and over. 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. Okay, so my line was off a little bit because of this grid. Okay, so that is a 180-degree rotation. He shows up right here, and my new point, instead of being at 4, 2, he's at -4, -2. That one's a little bit easier to see than 90 degrees because basically I'm just walking down and over to the origin, down and over. So whatever my original values are, I'm just negating them to shoot out the other side. For rotation of 270 degrees, that's the same as -90 degrees. So if I start here, I'm going to rotate all the way around until I end up down here. So that point ends up being 2, 2, 3, -4. And then finally, a rotation of 360 degrees. Basically, if I start here and I rotate all the way around, I'm going to be at the same point again. So that one's easy. The coordinates of the new point is the same as the old point. That's going to be 4, 2. So we don't need a rule for that one because you end up in the same spot. We do have a rule for the other three. And a rotation is denoted by a capital R. The O here means the origin, so I'm rotating about the origin, and that's the only thing we're going to be doing on the grid, is rotating about the origin. The first one is 90 degrees. If I start with XY, I'm going to end up at negative YX. That's probably the toughest one to memorize because you got to switch them and you only negate the front. XY maps to negative YX. 180 degrees isn't bad because if I start at XY, I'm just negating both. I'm going to go to negative X, negative Y. And all these you can do a sketch to try to remember the rule. You don't necessarily have to memorize everything. So the first term is a negative X, can't make that X very well, negative Y. And then for 270, if I start at XY, I'm going to switch Y and X, because if you look up here, here's my XY. Now I've switched the locations and I've negated the second value. So XY ends up at Y negative X. So those are the three rules for rotation. The biggest one is to remember the 90-degree rule. That's the toughest one to do. XY goes to negative YX. 180 isn't too bad, you're just negating both, and 270, if you can get 90, then you can use the 180 rule to get to 270, because you're just negating the 90 degrees. So we're going to run through a couple of examples, and then we will practice more in class. I have triangle cow. Again, my triangles are not showing up. Let me fix that if I can. Triangle cow has these vertices. C is negative 1, 2, O is negative 1, 5, and W is negative 3, 3. So let's graph that. Negative 1, 2, and that's C. O is negative 1, 5. This grid is almost too tiny for me to see. There's O. And then W is negative 3, 3. A teeny tiny triangle. And yours will probably be better than mine because you can use a straight edge. Okay, so there's the original. Now what we're going to do is we're going to graph and state the coordinates of C prime, O prime, W prime, which we are reflecting over one with the rotation, not reflecting, we are rotating 180 degrees. So that's the easy rule. The rule for this guy is XY is going to map to negative X, negative Y. So let's write the coordinates down first. C prime, if I negate both negative 1 and 2, it's going to be 1, negative 2. O prime, instead of negative 1, 5, it's 1, negative 5. And then W prime is going to be 3, negative 3. So let's graph that. 1, negative 2 is right there. There's C prime. 1, negative 5 is O prime. And 3, 1, 2, 3. Well, where's it? 1, 2, 3, negative 3 is right there. So there's your little cow triangle. And all we did, we used the rule to take this guy and rotate it 180 degrees through the origin. Now, if you do it correctly, you should be able to connect C and C prime, and they're going to connect through the origin, just like W and W prime, and O and O prime. They will all connect through the origin because that's where you're rotating. Now, when I look at what type of isometry this is, look at the order of the letters. COW. COW is going in a counterclockwise direction. And down here, the same thing. COW is still going counterclockwise. If it were reversed, it would be going this way. So this is a direct isometry because the order of the letters didn't change. And really, isometries are going to be direct unless you are reflecting over a line. Every time you reflect over a line, you change the order of the letters. So in this case, since it's just a rotation, it is direct. For our last example here, we have triangle ABC. It's a really ugly graph triangle, again, because it's tough to do that on my iPad. But here's triangle ABC. So I did step 1. Now we want to graph and state the coordinates of A prime, B prime, C prime, the image of triangle ABC after this little r represents a reflection, not a rotation. I'm going to reflect across the y-axis. So if you think about that, my rule when I reflect across the y is to negate the x values. So I'm going to state the coordinates. A prime, when I negate only the x, is going to be negative 4, 0. B prime is going to be negative 2, 3. And C prime is going to be negative 1, 2. So we can graph those. Negative 4, 0 is right there. There's A prime. Negative 2, 3. And you're going to see they're going to be a mirror image of the original. Negative 1, 2. So it's what you get if you were to fold this image across the y-axis. Those two sides would match up. Alright, well now we're going to graph and state the coordinates of the double prime, and this time I'm going to, my pre-image is going to be A prime, B prime, C prime. So I'm going to start with this guy. I'm not starting with ABC. I'm starting with the prime. This is another reflection over the x-axis. Little r represents reflection over the x-axis. So I'm going to take my A prime, I'm going to apply that rule, which means I'm negating the y. And you'll see that A double prime doesn't move because it's already sitting on the x-axis. But B double prime is now negative 2, negative 3, and C double prime is negative 1, negative 2. My negatives need to look better. So we're going to graph that. A double prime is the same spot. B double prime is negative 2, negative 3, and C double prime is negative 1, negative 2. So here he is. Well, if you look at that, if you look at the final image, this guy, and the original, think what single transformation could get me from ABC to A prime, B prime, C prime. And if you think about it and look, remember, I can connect my points, and they all connect through the origin. So think about what transformation that is. And we'll answer that in class. The other thing to think about is the isometry. When I go from ABC and I reflect over the y, right here my letters are in a counterclockwise direction. When I go to the single reflection, they are now clockwise. So going from the first image, or to the first image from the pre-image, is an indirect or opposite isometry, and then again from the second to the third is another opposite isometry. So when you reflect twice, you get a direct isometry again from the original. So as you think about what this single transformation is going to be, you end up with a rotation throughout the origin of 180 degrees. So reflecting over the x-axis and the y-axis together results in the same transformation as a rotation of 180 degrees.